Hi everybody. Here are the notes. For the first part of Unit 5, we're actually going to start at the end of Unit 5 and do vectors. The beginning part of this gives a lot of information. We're going to kind of do like an overview today, and then over the next few days go in detail over each piece. So this kind of gives you an idea about the definitions and some basic parts to vectors. A vector is a mathematical quantity that has both magnitude and a direction. And it's represented by a directed line segment, which is a ray, so that you can see where the tail is and where the head is. A component form of a vector is written, and that's in the directions there, or in the paragraph. Component form has these sort of pointy looking brackets or parentheses, and that puts it into a horizontal versus a vertical. So that represents your A and your B. So A obviously is left to right or horizontal, B is up and down or vertical. They will be positive or negative. Right here, standard position is another thing that's important. Standard position means the tail is at 0, 0. So the tail is the beginning and the head is the end. The magnitude, that notation looks like absolute value with the name of the vector inside. So a vector will be named by a lowercase letter, and then with like this ray looking thing, but only has half of an arrowhead on the top of it. That's the symbol for a vector. And then of course the magnitude is a squared plus b squared. We're not going to do too much with magnitude today. We're going to spend a lot of time on it tomorrow. So just to go back through some of those definitions, we're going to start by just drawing. So I'm down here on Try These A. So just to sort of help kind of go through, maybe a picture is a little bit helpful. It says draw vector V, and you can see it's in component form. And component form, remember, means horizontal, vertical. So you're basically counting. So if in standard form, that means it starts at 0, 0. We're going to go right 2 and down 5. Please make sure you put the arrowhead on the actual head, so the head is the end, and then also any picture, the vector needs to be labeled with its name. Vector U has a tail at -4, -2. So these are now in points, so these are places we're going to plot. So there's the tail is the dot, and it has a head at -2, -2. The head is, of course, the arrowhead, and then this is vector U. And then if we combine these things, it says vector T. This is the component form. So we start at, or the tail is at, -1, 2. Component form means horizontal 3, vertical 3. So you count right 3 and up 3. And then, of course, again, please make sure you put the arrowhead on the head and then name the vector, vector T. Now, in this next part, we're going to talk about how to take your points and put it into component form. Component form is essentially what we always want. We always want component form. Component form is how we'll get the magnitude. Component form is how we'll get the direction eventually. We're not going to do direction today at all. We'll do a little magnitude. So component form is head minus tail. Head minus tail. Tail is the dot, head is the arrow. And the order matters. It doesn't matter in terms of finding the distance. If we go from school to your house or from your house to school, it's probably the same distance if you drive on the same roads, but the direction matters. Right? Turning left versus turning right. The direction matters. So we have to make sure that we do it in the right order. Changing the order changes the sign, changing the sign changes the direction. So we're supposed to find out if each pair of vectors are equal. By supporting your answers, you're just showing your work. So vector V, and we can get the points right from the picture, which is nice because they went ahead and labeled the points for us. So vector V, we want to make sure we start at the head and subtract the tail. So we have, where's vector V? So -6 Just want to highlight it here. So we're right here. That's vector v. I'm going to do this in component form. -6 versus the tail, -2. And then we put the other 2 points together. -2 minus -8. Pay attention to your signs, and we get -8, 6. That is the component form of vector v. Now, vector u is in standard position, and it's easy to subtract 0, so -8 minus 0, and 6 minus 0, and so yes, these are equal. Equal vectors means they have the exact same component form, meaning they have the same length and they have the same direction. Now, how about vector u and vector t? Well, we already have vector u, so vector t, just to try this one more time. Again, you want to go head minus tail. So vector t is this one right over here. So it'll be 2 minus 8. And then, of course, 8 minus 2. And so this is going to be -6, 6. Well, no. Those are not equal, right? Because we want it to be -8, 6, so they are not equal. So just to try one more time with words rather than a picture, what's the component form of a vector with a tail at -8, 6 and the head at 12, -15? So again, start at the head. So 12 minus -8 and -15 minus 6. And so the component form of this is 20, -21. Now, I failed to mention at the very beginning of the whole thing, they talked about a robotic arm and how a robotic arm kind of represents vectors. Since vectors aren't anything that are real, they're going to use the robotic arm to represent the different things that the vectors can do. And so here, they give us some numbers, and we'll deal with the numbers here in a minute. Explain why a vector would be useful to represent the change of the position of the hand of the robot. So the robotic arm, the tail, if we were to think about this as a vector, the tail represents the initial position or the starting spot of the robotic arm. The head is its final position. Where is it trying to get to? How far over did it reach? Of course, the magnitude, this is the distance. And the distance comes from the tail or the start to the head, just to kind of put all these together. And of course, the direction, this is a little bit hard to use, not to use the word direction, but it is the direction of the movement. That it could be described as east, west, north, south. It could be described as left, right, left and down, right and up. So it's the way direction rather that it moved. It's a little bit hard not to use the word direction when defining that. So if we use these points that they just gave us, it says let vector v be the vector that describes the change of the position of the robotic hand, the one that they were just talking about. Just to give back the numbers, the robotic hand starts at 50, 120, and it ends at 98.65. Yeah, I just want to make sure I had that right. All right, so then to get the component form, all right, you would start at the head. This is the head. That's where it ends. It'd be 98 minus 50 and 65 minus 120. And so the component form of vector v, I should probably give its name, is 48, -55. And what does the component form indicate in this situation? Well, this means that it was in centimeters, 48 centimeters to the right and 55 centimeters down. Now for magnitude, and we haven't done magnitude yet, the formula was basically take your components, square them, and add them together. So we would do 48 squared plus -55 squared. Well, when you put this into the calculator, it works out to be 73, not a decimal, just 73. And the magnitude indicates that it's 73 centimeters from the initial position. So today is just really a lot of vocabulary. Obviously, it's a tiny bit of subtracting, but mostly the vocabulary. Standard position, head, tail, being able to draw them, understanding the symbol for the vector. Let's go back over what some of this means. I'm specifically looking at problem number 4. It says, give the meaning of each statement. And here we have the name is vector S, and its component form is 12, -8. So what does the component form really mean? Remember, it's horizontal and vertical. So the horizontal component is 12. We don't have any real application for this, so we don't really know what it is that's moving, but whatever moved 12. Whether that's north, south, so we can assume to the right. Vertical, the vertical component here is, of course, -8. So that's what that meaning is. So this means this is the vertical component, -8's the horizontal component, and that's the meaning of that statement. Now for part B, with the absolute value bars, with the name inside, this means the magnitude of vector V, or vector K rather, is 27. So how far that vector moved was 27. 27 was not clear. I'll show you this part. I know your assignment is this part right here. So just so you have it, on page 445, we got 6 through 10 all. Oops. So in case you don't have your book, here it is.